Hello guys, we are discussing how to find R equivalent when resistors are connected in series and parallel. So in my previous lectures, I have explained that how to identify the given elements are connected in series and the given elements are connected in parallel. So if elements are connected in series, so you know the formula, right? So if R1, R2 are connected in series, then you can replace with a single resistor with the value of R1 plus R2. This is what R equivalent when resistors are connected in series. Now the same resistors are connected in parallel. That means different current is flowing R1 and R2. So you can write R equivalent equal to so R1 into R2 by so R1 plus R2. So what you can understand from this, if elements are connected in same as in series, the current is same at R1 and R2. If elements are connected in parallel, the current will be different at R1 and R2, and that completely depends on what R1 and R2 resistance value. Now we already solved few problems on this particular topic. In today's lecture, we are going to solve two more lectures. Okay. Now see here, I have given a circuit. In that circuit, you need to find the current. Okay, the total current delivered by this particular source. So if you want to find I total current, you should know I equal to what? V by R equivalent. So you need to find R equivalent. So how many resistors are connected? N resistors are connected. So this N resistors you need to convert like this. So this is the single voltage source 120, and here we have R equivalent. So if you convert the circuit like this, then you can find what? The IT, total current delivered by this source. Now in order to find that R equivalent, so first you need to know whether these elements are connected in series or parallel. So in order to understand that, you can assume the current flow in the circuit, right? Now let us assume the IT is flowing from the source. What current is flowing? IT. Now after coming here, what happened? So this IT will go towards 8 ohm, 4 ohm and 3 ohm. Let us consider here we have I1 current is flowing where in 8 ohm resistor. This is what just our assumption. Now in 4 ohm resistor I2 is flowing. Now how much current is flowing? What current is flowing to the 3 ohm resistor? Therefore the total current IT minus I1 minus I2. Yes or no? Yes. Now the IT minus I1 minus I2 current is flowing to the 3 ohm and 9 ohm resistor. Now see here what current is coming? I2 current. From here in this direction IT minus I1 minus I2. Now these two currents will get combined. So after combination what happened? It will add I2 plus IT minus I1 minus I2. Therefore this I2 will get cancelled. Then how much current is flowing to the 5 ohm? Therefore IT minus I1. Yes or no? Yes. Now this IT minus I1 current is coming here and I1 current is coming this side. Now these two will get combined at this point. That means these two current will add. Therefore IT minus I1 plus I1. Therefore I1 and I1 will get cancelled. What current is flowing to the 12 ohm? IT. Now this IT current is going to where? In the source. Now is it correct? Your current assumptions are correct or wrong? See, if the same, what current is flowing from the source? IT. What current is coming to the source? IT. Therefore your current assumptions are correct. Now based on these current assumptions, you can identify that elements are connected in series or parallel. Now see what current is flowing in the 3 ohm and 9 ohm? Same current. Therefore these two elements are what? Connected in series. Therefore I can write 3 plus 9 ohm. Yes or no? Therefore this is what? 12 ohm. Now see, instead of this 3 ohm and 9 ohm resistor, can I replace with a single resistor with the value of 12 ohm? Of course. Now you need to redraw the circuit. Okay. Now this is voltage source and you have a various resistor. Here you have another resistor. Now see, instead of these two resistors, I have replaced with a single resistor with the value of 12 ohm. Yes or no? Yes. Now this is what? A 5 ohm, and it is like this, right? Yes. So here you have what? Another resistor is connected with the value of 4 ohm, and this is what? 8 ohm, and here this is 10 ohm resistor, and we have 12 ohm, and this is what 120 volt. Now see here, suppose let us assume the current is coming here. After coming here, some of the current is going to 12 ohm and some of the current is going to the 4 ohm. So the current is what different, right? Therefore this 12 and 4 ohm are connected parallel, right? If the current is different, these two are connected in what? Parallel. So therefore you know the formula of parallel, R1 R2 by R1 plus R2. Let us assume R1 equal to 12, R2 equal to 4. Therefore R1 R2 by R1 plus R2. Therefore here you can write 12 into 4 by 12 plus 4. Okay, this is 48 by this is what? 16. Therefore you will get what? 3 ohm. Okay, so here you will get 3 ohm. Now see, instead of this 12 ohm and 4 ohm, can I replace with a single resistor with the value of 3 ohm? Of course, why not? So here this is my voltage source 10 and this is 8. So these elements I didn't change yet. So here we have 5 ohm, I didn't change. So instead of 12 and 4, I'm using a single resistor with the value of 3 ohm, and this is my 5 ohm resistor. Here you have 8 ohm, and this is 10 ohm resistor and a 12 ohm resistor, and this is what? 120 volt. Now see, the same current is flowing in the 3 and 5. Therefore I can add 3 plus 5. This is what? 8 ohm resistor. Now can I replace this circuit? Instead of this 3 ohm and 5 ohm, can I use single resistor with the value of 8 ohm? Of course. Now I'm using single resistor with the value of what? 8 ohm. So here you have what? 8 ohm, and this is what? 12 ohm resistor, and this is what? 10 ohm resistor, and this is what? 120 volt. Now see, this 8 and 8 are connected parallel. So how to identify that are connected parallel? Let us assume current is coming here. Some of the current is going to the 8 ohm and some of the current is going to the 8 ohm. So different currents are flowing. Therefore 8 and 8 are connected parallel. So 8 into 8 by 8 plus 8. So you will get what? 4 ohm. Now instead of these two resistors, can I replace a single resistor with the value of 4 ohm? Yes. So this is voltage source. You have 10 ohm, and here you have what? 12 ohm, and instead of these two resistors, I am replacing a single resistor with the value of 4 ohm. This is 120 ohm. Now see, these three elements, these three resistors are connected in series because same current is flowing. Therefore 10 plus 4 plus 12, 20, 24 and 26 ohm. Now instead of these three resistors, I can replace with a single resistor with the value of what? 26 ohm. Now this 26 ohm is what? R equivalent. Yes or no? R equivalent. See, various resistors we have converted into single resistor. Then how to find I? So IT equal to, okay, V by R. So V by R equivalent. So voltage means 120 by and 26. If you cancel this one, you will get what? 4.6 ampere. Okay, 4.6 ampere. So 4.6 ampere is the total current, and that is supplied by what? 120 volts. What? Okay, and this is the procedure to identify R equivalent, and at the same time to find R, to find the total current. Now another problem, the last problem in this concept. See here, I'm not going to explain much because you already know how to identify that these are connected parallel or series. Now if you assume the current direction, so you can understand that if the current is coming here, some current is going here and some current is coming to the 4.7 kilo ohm. This is 4.7 kilo ohm and this is 5 kilo ohm. Therefore 5 kilo ohm and 4.7 kilo ohm resistors are connected in parallel. Therefore 5 into 4.7 by 5 plus 4.7. So if you solve this, you will get what? 2.42 kilo ohm. Now instead of these two resistors, can I replace a single resistor with the value of 2.42? Of course. Now here, I don't need to find the total current, just I need to find what? The R equivalent. Now instead of these two resistors, I'm going to replace with the single resistor with the value of 2.42 kilo ohm. Okay. Now this is what? 4 kilo ohm, and this is 3 kilo ohm, and here this is 10 kilo ohm. Now see, same current is flowing, therefore 4 plus 2.42, okay, therefore this is 6.42 kilo ohm. Now instead of these two resistors, can I replace a single resistor with the 6.42 kilo ohm? Yes. Now this is the voltage source, 10 kilo ohm, and we have 3 kilo ohm, and we have what, 6.42 kilo ohm. This is what, 6.42 kilo ohm, and this is 3 kilo ohm, and this is 10 kilo ohm. Of course we have voltage source with the value of 5. Now see, current after coming here, what happened, some current is going to the 6.42 kilo ohm, and some current is going to the 3 kilo ohm. Therefore 6.42 is connected parallel with what, 3 kilo ohm. Therefore you can write 6.42 into 3 by 6.42 plus 3. Therefore if you solve this one, you will get what, 2.04, okay, 2.04 kilo ohm. Yes. Okay, now instead of these two resistors, can I replace a single resistor with the value of 2.04? Yes. Now we have a voltage source, and we have one resistor, that is 10 kilo ohm, and instead of these two resistors, what, another resistor, that is what, 2.04 kilo ohm. Now this is what, 5 volts. Now see, if the current is coming here, some current is going this way and some current is coming this way for 10 kilo ohm. Therefore this 2.04 connected parallel to what, 10 kilo ohm. Therefore we have formula 2.04 into 10 by 2.04 plus 10. Therefore if you calculate this one, okay, you will get, 1.69 kilo ohm. Okay, so you will get 1.69 kilo ohm. Therefore see, instead of these two resistors, you can replace a single resistor with the value of what, 1.69, and it is approximately what, 1.7 kilo ohm. Therefore what is our goal here, we need to find only R equivalent. So R equivalent equal to what, 1.69 kilo ohm. If you want to find current I equal to V by R equivalent, then you can submit 5 and you can submit 1.69 kilo ohm. Therefore you will get what, milliampere, some x milliampere. Okay, I hope you understood that how to find R equivalent when resistors are connected in series and parallel. Okay, thank you.